Okay, here we are again with some more Hess's law questions, and this time we're asked to find the enthalpy change of formation, or the enthalpy of formation of ethanol, given some enthalpies of combustion. If you remember, Hess's law is really good for finding out enthalpy changes which are incredibly difficult, or if not impossible, to find in a lab. And you can imagine that trying to carry out an experiment in which you take carbon and oxygen and hydrogen and react them to produce ethanol isn't going to happen, right? Now just remind yourself, maybe pause here, that equation I've just written out there represents the enthalpy change of formation of ethanol, forming 1 mole of the compound from its elements in their standard states. I'm not bothering to include the standard state symbols in this example. Enthalpies of combustion, on the other hand, are really easy to find out because we can burn stuff dead easy. It's fun as well. So if we again form a Hess cycle from this, then we can use those enthalpies of combustion to find this enthalpy change of formation. Remember, Hess's law says that the energy that accompanies a chemical reaction is independent of the route by which it takes place. So if we start by burning some carbon, we end up producing carbon dioxide. And if we burn 2 moles of carbon, we get 2 moles of carbon dioxide. So that enthalpy change is the enthalpy change of combustion of carbon, but there's 2 of them. We don't burn oxygen because oxygen is a reaction with itself. Burning is a reaction with oxygen in itself, so we're not going to include that. We can burn hydrogen though, very explosively as it happens. If you burn 3 moles of hydrogen in oxygen, you get 3 moles of water. So that is 3 times the enthalpy change of combustion of water. Okay, now to finish our Hess cycle, we just need to take the ethanol and burn that. Because if we burn 1 mole of ethanol, we get 2 moles of carbon dioxide and 3 moles of water. So this represents the enthalpy change of combustion of ethanol. And you'll see we have all of those values: the carbon, the hydrogen and the ethanol. So using Hess's law, let's give him a bit of credit. He did come up with this, so it's nice to quote him. Using Hess's law, the enthalpy change of formation, the one we're trying to find here, is equal to this. We're going along the same direction as the arrow this time, so it's twice the enthalpy change of combustion of carbon, plus, because we're going again along the arrow, plus twice the enthalpy change of combustion of hydrogen. Now we're going back against an arrow here, back against an arrow in this direction, so minus the enthalpy change of combustion of ethanol. So if we substitute our values, twice, that gives me, twice times negative 393 plus 3 times negative 286 plus, no, not plus, minus, because we went against the arrow, minus negative 1371. And if we solve that, we'll find that we get a value of negative 273 kilojoules per mole. Voila. Do notice that, as you'll probably notice, that some of the values for these enthalpy changes of combustion or formation are slightly different to the ones in your IB data booklet. These questions I got from our friend Grimes' website, Chem Sheets. Thanks again, Richard. Good night.